Hi guys and welcome to Codeforces D4 round number 790. As you can see, the contest is still running, and I already solved all problems. But before we jump into the problems, I want to ask you, what was your favorite problem from this contest? Leave a comment down below. I really want to hear what kind of problems you expect to come up more in D4 competitions. So in problem A, we were given a ticket number, a bus ticket number with 6 digits. Some of them, including leading digits, can be zeros, and we wanted to check if it's lucky or not. As you may know, a ticket is considered lucky if the sum of the first half of the digits is equal to the sum of the second half of the digit. So obviously this is just an exercise problem. And my solution is not the prettiest one, but it works. So instead of calculating two sums, each on their own, I compute the difference. So first I add 3 numbers, then I subtract 3 numbers. It probably, there are too many ways to do it, to describe all of them. I did it this way. And -0 is probably not necessary here because it will be subtracted and added the equal number of times, but whatever. So yeah, I will not go too deep into problems that are just like exercise, check if you know how to program. In problem B, equal candies, we had several candies and we wanted to equalize them, and for that we were allowed to subtract 1 from each box as many times as we needed. And we needed to find what is the minimum number of operations we need to perform, what minimum number of candies that we need to eat to equalize the boxes. So for this problem, first we need to find what will be the equal number, the optimal equal number. It must be clearly less than or equal to each element of array A, so I just take minimum and I claim that it's optimal. It's clear that no bigger element can be achieved, because elements of A cannot increase. So this is the maximum element such that all elements can be made equal to it, maximum number. So it's clearly optimal. And then I just compute the number of operations needed for each box to convert it to this number. So yeah, another implementation problem. In problem C, I already forgot what the problem is about, and Codeforces is kind of slow. Actually, I can do that, right? Also, in problem C, we had several strings, and the distance between strings was defined as follows. So strings were of the equal length, and for each position, we were allowed to change each character to next or previous in the alphabet without looping. So we needed to find the 2 strings that are closest together in a given set. Basically the same thing. And also the number of strings was kind of small and strings themselves were kind of short. So in this problem, just naive approach works. Check for each pair of strings, compute their distance between them. Distance can be computed as we take bigger of 2 characters and subtract smaller of 2 characters. Also, absolute value of A minus B would have worked. I don't know why I wrote it this way. Don't ask. Oh, actually, I wrote it this way because originally I thought that cyclic changes are possible. Like, it's possible to go from Z to A, but it was not, so had to modify already existing code. Now problem D, we had a matrix. We wanted, each cell had a non-negative integer. We wanted to place a bishop in some cell in such a way that sum of targeted cells is maximal. So because of the constraints of the problem, it was possible to write brute force, that is, check for each cell what is the sum if we place bishop there. Because the complexity of such a solution is of n times m times n plus m, which, considering this constraint, was bounded by something like 10 to the 7th. So we do just this, and convenient way of iterating over several directions outgoing out of some cell. So you create array of differences. That is like your what steps are you going to make. So this like goes to the left and upwards. This goes to the left and this actually goes upwards and to the right, etc. And then you can just initialize either skip or not skip first element, and then you step until you are within the grid, step by given step, and increment your sum. Then you take maximal. So yeah, in this problem, the hardest part was realizing that because of this constraint, naive solution actually works quick. Of course, you can solve it in O of n times m time, which is a good exercise. Good exercise if you have never solved such problems before. If you solved it and you can immediately see, then you can skip it. In problem E, so we had several candies. Each candy had some sugar in it, some amount of sugar. We are given several queries. We wanted for each query to find what the minimum number of candies we can eat to have at least that much sugar. So for this problem, you need to make several observations. First of all, it's clearly optimal for each query to eat the candies with the maximum amount of sugar in them. So first thing you can do is immediately sort array descending. And then you kind of need it, like, once you sort array descending, then eating k candies corresponds to having taken k's prefix sum. So let's just compute prefix sums, which can be done in place, by the way. And then finding answer when we have array of prefix sums is just binary search, which in C++ is lower bound. And there was also a case when it was not possible, even eating all candies would not suffice to get given amount of sugar, then you just put -1. The only tricky thing in this problem is that if you take position of this iterator, then you also need to count this position, so you add +1. In problem F, we had an array. We needed to find two numbers left and right such that for each integer between them, it appears at least k times, and also their difference is maximized. So like the longest window in which all elements are quite frequent, at least k times appear they. Also sometimes such no numbers are frequent, then we had to output -1. So obviously you need frequency map for this, or frequency table, array, whatever you call it. Then because how map works, you want to consider all candidates, all values x, such that their frequency is at least k, and you want to consider them in order, and map provided to you with naive iteration. So we maintain the length of the current window of like the last good value of x, maximum right minus left, and also best right, the one that achieves maximum. So if current element adds to the current window, then we increase the length of the window. Otherwise, we reset the length of the window. We update last good element to x. If current window is longer than maximum element, then we need to update it, and we need to update right endpoint, which becomes last. This also needs to be done in the end. I actually don't know. I don't think that it needs to be done in the end. Like the way I originally wrote it, it needed to be done in the end as well. But I think that now that I think about it, does not need to be to happen in the end, because I check all the time. Like if I only checked here, then maybe it needed to be done. I don't know. No, if I only checked here, then here it also needs to be done. Okay, and then you like if you found any window, then you can from best right and length of the window you can restore left. Otherwise you just say -1. So problem G. White, black, balanced subtrees. We had a tree, a rooted tree. Each vertex had a color. We needed to count number of balanced subtrees. Subtree was called balanced if it had equal number of white and white and black vertices. So this is just DFS, of course, and the only implementation detail is instead of counting black and white cells separately, you can introduce balance as the difference between the two, and then you just check your balance is 0. So you do your DFS return number of return the balance from subtree, calculate the balance of the current subtree, balance is 0, count this subtree, that's it. So yeah, problem H actually had 2 versions, but I already immediately went for the second one because it was just obvious. As problem H2, we had 2 rows like this in order. For each, you can see that each segment on top, it has exactly 1 edge or line outgoing out of it, and we were given the segment that it is outgoing to. So like A1 is 4, in this case it means that from first segment you go to 4th. A2 was 1, so from second segment you go to first. A3 was again 4, so you again go to 4. And now that you understand the input format, you are tasked with counting the maximum number of intersections that you can achieve. Like here, remember how I said that 1 goes to 4 and 3 goes to 4? They can actually intersect, so we should count it in the maximum intersection. So here, all you needed to notice, first of all, in such counting problems, it may be hard to count intersection points directly, so we need to group them by wire. Let's say we group them by a second wire, so like this intersection between first and second wire will be counted in the second wire. This intersection between the first wire and the third wire, the added circle, it will get counted in the third wire. So whatever is the second wire, you may think of it as like placing physical wires, and the ones that on top, we count intersections when we consider the ones that goes on top. So now for each of these wires, let's think what is the maximum number of previously placed wires that we can intersect. Well, obviously we can intersect anything that was going to, let's say for the third wire, right? It goes from third to fourth segment. It can intersect everything that was previously placed and goes to fourth, fifth, sixth, seventh segment. So yeah, it was like suffix sums queries. And except that, we also needed to actually place the wire, so add 1 to this segment. So a data structure that is capable of telling you range sum queries and also point update queries is fanvic3. So I did just that. I went ahead, copy pasted it from Editorial library. And I create fanvic3 and I say okay, count me number of wires previously placed that go starting from our segment until the end, because I can intersect all of them. And then I just add 1 wire to the current segment. So that's it. So the actual solution is super short. And of course, Editorial implementation of fanvic3 is rather long. And I also need to copy paste some type traits file. So yeah. fanvic3, if you don't want to use Editorial library for whatever reason, then you can write your own fanvic3 that will be 10 lines long. maybe even shorter. So yeah. And I did fennec tree because in second version n was up to 10 to the 2 times 10 to the 5th, so there is no cheesing it. Or in the first version n is up to 1000, and you could have counted suffix sums naively by just maintaining like frequency array, right? So that was probably the intended solution for each one. So yeah, that was the contest for you. Thanks everyone for watching. And before you leave, please let me know what was your favorite problem in this contest. I really want to know. So yeah, guys, bye-bye, and I'll see you tomorrow with Concept Starters.